Hi, welcome. In this video, we're going to be looking at the nature of organic molecules. So first thing that we're going to ask is, what is organic chemistry? Well, organic chemistry is the study of compounds of carbon, right? These are compounds of carbon other than the oxides and maybe the sulfides of the of the element. Now, carbon is a unique nature in that it can form long chains with itself. So it can form long chains with itself in the form of simple bonds or multiple bonds. By simple bonds, we would talk of carbon-carbon simple bonding, or carbon-carbon double bonding, carbon-carbon triple bonding. It can actually even form ring structures. This phenomenon is referred to as catenation. So carbon can catenate or form long chains with itself. But we are not going to go into the intricacies of the catenation of carbon. So that is the main study of the organic chemistry that you're going to be looking at. So the important things that you need to know is that in as far as the matric syllabus of the NSC curriculum is concerned, is that you need to know a total of 9 homologous series. That we are going to look at, and basically the 9 are: 1 are your alkanes, your alkenes, your alkynes, and these here are basically referred to as the hydrocarbons. We will explain the meanings of all of these terms as we go on. You're also going to look at the derivatives of these hydrocarbons, and these derivatives being, you are going to look at your haloalkanes, you are going to look at your alcohols, then you are also going to look at aldehydes, there will be ketones, and then there will be carboxylic acids, and last but not least, there will be esters. So these are all derivatives of the derivatives of the organic molecules of the hydrocarbons. Right? So what are your hydrocarbons? Basically, your hydrocarbons are compounds, organic compounds, which consist of carbon and hydrogen atoms only. So these are made up of carbon and hydrogen atoms only, whereas your the derivatives of those hydrocarbons will include your halogens for your haloalkanes. They'll include oxygens, and yeah, mainly so carbon. They will include halogens and oxygen in their structures. So those are the 9 groups that you need to be familiar, or you need to study and ensure that you know. However, before you even get to all of that, there are basics that need to be known, such as the very definitions of what is meant by a homologue, what is meant by a hydrocarbon, what are each of these, how do you know what compound you are dealing with, and when do you get that compound, etc. So we're going to have a look at all of that as we discuss this further. Right, so what must you know? What are the key things that you need to be familiar with when you're going to study the organic chemistry? I am going to now first look at the important things that you need to be familiar with. And the first one that we're going to look at is the nomenclature. Right, so the nomenclature is nothing other than the naming of the substances. So your nomenclature is the naming of substances. This is key, it's fundamental, and before you can actually work with any of the organic compounds, you need to be able to name them. And how do you get to name them? Well, the naming depends on essentially depends on the number of carbons that the compound has in its parent chain. In the parent or the main chain. So what are we referring to as the parent chain? The parent chain is nothing other than the longest continuous carbon chain. In the molecule. So that's in the molecule or the compound in question. So now, how do we know? How do we determine how to call them? How do I know that this is going to be an ethane? How do I know that this is going to be propane, methane, etc.? How do I know that? Well, the first thing that you need to be able to do, in order for you to be able to do that, one, you need to be able to determine the number of carbons. So the number of carbons determines the name. So number of carbons determines the name. So now, what are these stems or the root names? Right, so I'm going to give you those. So when n is equal to 1, then this is the root. So when n is equal to 1, that's the number of carbons, is equal to 1, so the root is going to be meth. So whenever you have an organic molecule or an organic substitute with the number of carbons having one carbon, its base name is going to be meth. Whatever it is, it's going to have a meth. And then when there are two carbons, when n is equal to 2, the base name or the root name is going to be eth. And then when there are 3 carbons, it's going to be prop. 4 carbons, it's going to be but. 5 carbons, then you start thinking of polygons. Think of a 5-sided polygon, right? I'm just going to use different color. 5-sided polygon is a pentagon, but in this case it's going to be a pent. And then 6 is going to be 6, 7, 8. 6 is going to be your hex. 7 is your hept. And 8 is your oct. 9 is going to be nonane, decane, etc. So now, having done that, you are now in a position to look and say, okay, fine, what is the number of carbons? Therefore, I can determine the base name, so a root. That's the root. Whether it's so if it's got 4 carbons, I know it's but. If it's 5 carbons, pent. 7 hept. 2 eth, etc. But before I can actually give a full name, I need to know with what I am dealing. And that which you are dealing is actually referred to as a functional group. What is it that you are dealing with? And then that will enable you to give the full name of the organic compound. So I need to know that which gives the characteristics of the substance and which is referred to as the functional group, right? So we are now going to talk about the functional group, what is meant by the term functional group, right? The functional group, I'll just quickly write that here, what the functional group is. So the functional group is a bond or an atom or a group of atoms. So this is a bond or an atom or a group of atoms that determine or determines the physical and chemical properties or characteristics of organic compounds. So that functional group is then going to, so for a family of compounds that are the same, the functional group is also going to be the same. I will repeat that. So for a group of compounds that have the same functional group, their characteristics are going to be the same. Those families are referred to as um, homologous series or families or groups, right? So functional groups, so this is the functional group. Maybe I should just quickly, so it's a functional group. These would then cascade or lead to your homologous series, right? What are homologs or homologous series? These are groups of compounds that belong to the same family. So it's a series of organic compounds. It's a series of organic compounds that can be described by the same general formula. So they're a family, right? Or alternatively, you could say, in which one member differs from the next with a CH2 group. So now, what do I mean, or where do we now start talking about the homologous series? I'm just going to keep it here for now, and then I'm just going to go back again to this naming that we had started. We have various functional homologous series that we have, right? So these homologous series are going to then enable us to give the full name of the organic molecule. So for example, if we have something like your alkanes, your hydrocarbons, I'm going to talk about the hydrocarbons in this particular video. The first one that I'm going to refer to is if I have a group of compounds, so this is the homologous series, the alkanes, and I have an alkane, these are the most basic of the hydrocarbons, of the organic molecules, your alkanes. Those alkanes, they have a general ending. They will give what we call the, so if that is the root, and then the other part becomes the ending or the suffix of the name. So now that suffix becomes an ane. So they have an ending, ane. So all of these will have an ending, ane, because all alkanes belong to the same homologous series, and therefore they will have the same ending. Right? Remember we said that alkane homologs are series or families, so they will have an ending ane. So if we have to give the full name of a compound which is an alkane which has got one carbon, the name is therefore going to be methane. So the stem from the number of carbons and the ending from the homologous series to which it belongs. So in this case, you're going to have your methane, just one word, and then the next one is going to be ethane. The next one is going to be propane. Next one is butane. Next is pentane. Next one is hexane, heptane, and octane, nonane, decane, etc. So that is how you would name the alkanes, right? So remember, check the number of carbons that you have, and then from there you would then look at the prefix that you're going to use, and in this case, if it's got 1 carbon, it's meth, 2 eth, 3 prop, 4 but, 5 pent, 6 hex, 7 hept, 8 oct, and then the ending for the alkanes is always going to be ane. So it's going to be methane, ethane, propane, butane, pentane, hexane, heptane, and octane. And obviously, I'm sure you would be then wondering or asking, how do I know that this is an alkane? How do I know that this is another compound other than the alkane? That is what we're going to be looking at in the next video. So if you like this video, please share, like, send us your comments, and then subscribe to our channel. See you in the next video.